One of the questions we frequently get is how to figure out the machinability number for a material that's not in our material database. So I've got another video that walks through how you can do some cuts to test out that. As a prior step to that, there is also this website from Hypertherm that has a pretty extensive list of materials. You can just search for Waterjet calculator Hypertherm, should bring you to this page here. And top right hand corner you can choose to install the desktop app, or you can also install the Android or Apple app depending on what you're using. And you've also got settings for whether you want to do imperial or metric and such. Key thing is over here on the left side, you choose your pump size, so there will be slightly different operating costs for each of these pumps, but the key thing would be choose your proper horsepower. And then you've got your material list here, so yes, quite an extensive list here. The number in parentheses is the machinability number. If you're using WardCam, you would just type that number in. If you're using iGEMS, then you do have to do a bit of a conversion. iGEMS bases basically everything off of steel as an 87.6 machinability number. So basically you'd use a number 68% of the 87.6. And if we're doing that in WardCam, we'll switch over to that. So on the right here, we got WardCam. You can go into the, of course, go into the material database. I usually start with something. You can just start with aluminum, whatever. Down here at the bottom, click on Add Material. It'll make a copy of whatever you've selected, and then you can rename it. I'm not even going to try to spell this correctly. Whatever. And plug in your thickness, and plug in the machinability number, and then click on Calculate. And the numbers here should be pretty close, especially the smoothest through the fast. The fastest WardCam usually sets halfway between the Q1 and Q2 speeds that we would see in this calculator. So if I go back to the calculator here, and we scroll down a bit, so down here at the bottom, based on the nozzle orifice combination and thickness, abrasive flow rate, pressure, it'll show you the range of cutting speeds. So the Q1 that they have here, separation, that's where you would just barely be getting through the material, and that's more of what everything else is based off of. So you're probably never actually going to cut at the Q1 speed. And as you see over here in WardCam, we've got that set a bit lower than that, whereas the other numbers are fairly close to what they've calculated here. And as you click on these, it'll show you what the edge quality would look like. And then as you change that, it's also going to show you information up here as far as cost per inch and such. So as you change this, your cost per inch will also change. Well, you can plug in up here at the top, you can plug in your different cost factors. It'll give you operating cost estimates over here on the right. So quite a useful website. And we'll save that in WardCam. So in iGEMS, we'll bring that up. We would go into our material database, and we can go to the top level of steel. If we go to the general tab, we see that steel is usually set to 87.6. If you click on the little question mark, it gives you some other numbers. Don't have molybdenum in here, so I'll make a new material. So go to top level of your material, hit the plus button, put in your name. Awesome spelling, yes, thank you. And then on that general tab, so we're going to do 68% of that number, 87.6 times 0.68. So we'll just start at 59.5 and see where we come in here. And then we'll go down to our 1 inch. And we'll bring up that calculator again. So iGEMS uses a little bit different algorithm for calculating the feed rates, but they should be in the same general ballpark. I usually look at the Q3 as a starting point, so we got 1.5 versus 1.7, excellent 1.0, so we maybe could bump up that machinability a little bit here. So they've got the extra rough at 3.3, so we'll just go up to the top here, and let's try 65, see if that goes too far. 1.66 versus 1.7, so that looks pretty reasonable. Of course, you could always tweak that a little bit more if you wanted to. That's a quite helpful website, the Hypertherm Waterjet calculator. If you have any questions on that, let me know. Thanks.